Hi there. In this lesson, we are going to get to do inference for two independent means. So since you've had a lot of practice already, we're going to do both hypothesis testing and a confidence interval in the same lesson. Okay? So let's look at the example we're going to start with. Researchers did a study with 4-year-old children on whether watching 9 minutes of a fast-paced cartoon would affect self-control, the ability to delay gratification, and working memory. Okay, what do you think? Do you think this would make a difference? They did an experiment. 60 kids were randomly assigned to one of the 3 groups that did one of the following activities for 9 minutes. Okay, so there were 3 different groups. Watching a fast-paced cartoon, watch a slower-paced educational program, or coloring with markers and crayons. Okay, we're just going to look at 2 of these groups today because we're talking about 2 independent means. In the future, we will look at 3 or more means. Okay, so let's go down, get a little more information. The children selected for the study had no differences in attention or amount of TV usually watched. Okay, so they're trying to control for these other factors. We have the data on the wait time the time waited to push a button for a treat in seconds. Okay, so we have time waited to push a button for a treat in seconds. And we have data, I'll show you the data. We've got it in a Google Sheet, so you should be able to see that. Now, one thing to note, in a lot of these published studies, they don't always publish their raw data. So sometimes what stats teachers do is they take a study and they make this data based on their results, their summary statistics. It's not the exact actual data, okay? And so that's what's been done here. We have the time waited to push a button for a snack in seconds. Here's the group of kids. So each one's a different kid, their wait time for who watched the fast-paced cartoon, okay? And there's 20 in each here. And then here are the wait times for the educational group, okay? Okay, it's interesting that there's some zeros here and 5 and 7, but then also actually the wait time, higher wait time is better, right? Delayed gratification. Okay, never mind. So these are looking higher, but then some lower as well, but then at the end turns out higher. So these are in order. So it'll be really interesting to look at this data. Okay, let me go back to the notes again. Let's do a hypothesis test. Do you think there would be a significant difference between the time waited for a snack between these 2 groups? And remember, they're watching these for 9 minutes, okay? Interesting. So they did one of these 3 for 9 minutes. We're going to compare the cartoon with the educational group. So I'm going to label these with a C and an E. C for cartoon and E for educational. That way we can distinguish between the 2 groups and we can write our hypotheses, okay? So remember, the null is going to be no difference. The null is dull, or what we would expect. The alternate is usually what we're trying to show. Okay, so the null will be mu for the cartoon group minus mu for the educational group equals 0. No difference between the groups. And I'm also going to write 0 seconds just to remember what this 0 actually means. Then the claim, you could think the researchers are probably trying to show that there is a difference, right? So we're going to say mu C minus mu sub E is different from 0 seconds, okay? It also could be framed as a right tail test. Do we think, or actually this one might be left tail, do you think the cartoon wait time is less than the educational group? Or we could flip the subtraction and make it a right tail test. This one is framed as a 2-tail test, significant difference. Okay, and then also keep in mind that sometimes some people prefer to just do a 2-tail all the time because it's more conservative. Your p-value, because you're multiplying it by 2, it's a more conservative test. Okay, so now we're going to enter the data into Staplet. We're going to switch to a new Staplet or different one of these. There's a one quantitative multiple group. So we've been using the single group, but we're going to get to use the multiple groups now. And then we're going to label the groups and include units, of course, okay? Then we'll use the summary statistics, and what we need is our observed statistic, right? Observed statistic or point estimate. Usually we call, for a hypothesis test, we call it the observed statistic. For a confidence interval, we call it the point estimate, but it's the same thing, right? It's what we got, it's the results from our sample. So what we're going to be looking for there is X bar, because it's from our sample, for the cartoon group, minus X bar E for the educational group. Okay. All right, so let's grab our data. And I am going to copy the headings this time. And let's go over to Staplet. You probably have a direct link, but in case you're at staplet.com, I'm going to select one quantitative variable, multiple groups. And, oh great, there is a variable name. So I just selected the group one name. I'll go back and do the title in a second. I'm going to go up here and do the overall variable that we are doing. And now I'll go ahead and grab the data. So we do have to do these in a few different pieces, but it transfers pretty seamlessly from MyOpenMath and anything like that. Okay, and then let me go and get the educational group. Okay, great. Now we're going to stick with 2 for now, but when we get to 3 or more, we'll be able to add a group to this, which is really nice, but I don't want to do that now. I'm going to click Begin Analysis. Oh, and we're sticking with raw data, which is the default option. There is another option for just means and standard deviations, just like the single group. Okay, so we'll come back to conditions. So we might have to look for nearly normal here, just like you're used to. But I want to do the simulation first, since we don't have to do conditions for that. And we need to get, here's our summary statistics. We need to find the difference of the two means, right? So we've got 19.7 minus 33.85. All right, that's our X bar. You could label it X bar 1 and X bar 2. I just like to use a letter so I remember which group it is. So let's go back to the notes and write this down. So 19.7 minus 33.85. Seconds. Okay, so I've got my 19.7 minus 33.85 seconds. Let's see what that's equal to. Okay, negative 14.15 seconds. Okay, so interesting that it came out negative, right? Which kind of makes sense if we're expecting the educational group to have a longer wait time. So this is similar to when we did paired differences. You can switch the order, right? It just changes the signs and it changes the interpretation. So just notice as you're doing practice problems, make a note if it tells you the order to subtract. That way you'll get the right answer that's programmed in. If it doesn't say, some problems are coded to accept it either way, okay? So let's see what happens with this negative value. Also, I guess if you're doing a right or left tail test, that might also make a difference. Since we're doing a two-tail test, it really could be either way. Okay, so first we'll do a simulation because we don't need to meet conditions for that. And I'll explain a little bit how the simulation works. Let me get my pens all over here. So remember when we did the dolphin experiment with the little cards? Okay, so this one's actually a little bit easier than that. If we were to do this physically with cards, what we would do, let me go back to the data. We would have a card, so we've got 40 observations here. We would, let me get rid of that. We would take each of these numbers and put them on a card. And remember the null, we're simulating the null, which means no difference. So we would just say that any difference between these groups was just due to chance. And we would take all the 40 cards, shuffle them up, and deal them out again 20 and 20. And then take the average of each group and then subtract to find the difference. Okay, so what we would do is we would see what differences are likely if there is no actual difference. Okay, what differences are likely under the null. Okay, so that is what Staplet is going to do for us. So there's some different options. Simulate difference in two means, difference in two medians, or difference in two standard deviations. Okay, those are our three options. So we're going to stick with two means. And it describes it here. So this should describe what I just said. Simulates the distribution of the differences in sample means when the observations are combined, shuffled, and redistributed into two groups that match the sizes of the original groups. Okay? Exactly what I just said in a different way. Okay, so that is what we want. We're just reshuffling under the null, assuming there is no difference. Okay, so let me add 2,000 samples and add trials. Okay. Okay, great. So remember, 0 should be in the middle. The null value should always be in the middle, so always double check that. And we don't have our original sample, like StatKey gives us our original sample right here. Staplet does not. But that's okay. We got it from our summary statistics above. And this one, you'll notice, also does not have a confidence interval option, so it doesn't do bootstrapping for two means. I'm not sure why, but it doesn't. So we are going to count the number and percent of dots either less than or greater than or equal to our observed statistic, right? So this is what's likely with these particular data values if there really is no difference, okay? And so we want to know how likely is our negative 14.15 under the null. Now because it's negative, I'm going to go less than, because we're always going towards the tail, right? Away from the null, evidence away from the null. So I'm going to stick with less than or equal to negative 14.15 and count. Okay, so you can see there's just a few over here. 14 dots or 0.7%, so 0.007, quite small. And then because it's a two-tailed test, what do we have to do? I'm going to change the, well, I'm going to go back to the notes and highlight a couple things that we just did. Okay, so we did simulate difference in two means, add 2,000. That's really all we had to do on that. So let me go to the next page. Okay, great. And this is describing our process here. Now we want to know how likely it is to get a difference as large as our observed statistic or further from 0 or more extreme or toward the tail in our simulation of the null hypothesis. Okay, and it also gives us our significance level of 0.05. Okay, so this one has 0.8%, so very close. So we, because our observed value, it's really a difference, our observed difference is negative. So we're going to go to the left. Count to the left. Okay, and write down our simulated p-value. Now I could write down the one that I just got, or because just to be consistent with the notes, I'm just going to write this one. And then if you're looking at it later, it'll match up. So our p-value, and let me circle this right here. That is the p-value, but it's only for one side. It's also for one tail. Staplet doesn't have a two-tail option. So the p-value is 2 times 0.008 or 0.007 or whatever you get, which is 0.016, I believe. Let me double check that. 2 times 0.008, yes, 0.016. Okay, and that is, either way, it is quite a bit less than 0.05, right? Okay, this is great. So it looks like this difference is significant, right? Very unlikely under the null. Okay, if the difference was somewhere in here, it would be much more likely under the null. Okay, let's write our conclusion in context, talking about the difference in the two means. Okay, great. So let's write our conclusion with a p-value of 0.016. We reject the null. Hypothesis. There is evidence, or you could say strong evidence, there is evidence of a significant difference in the average wait time. So that's what we were measuring in the average wait time for a treat between, I want to describe the two groups, between kids who watch fast-paced cartoons versus educational programs. Okay, now this was a randomized controlled experiment, so we can conclude causation. So I am trying to infer back to the population rather than talk about just the particular sample that we have. Okay, so just be careful with your wording on that, just like for confidence intervals. Okay, now one more note at the bottom here, and we kind of saw it. Staplet does not have a bootstrapping option for two means, unfortunately. Okay, now StatKey does, but the data have to be formatted differently. So let me show you that real quick before the end of this video. We will use it a little bit, but the data have to be formatted a little differently. So here's StatKey. If I go for test for difference in means, this one is leniency and smiles, which you may have seen before. Is a judge more lenient with sentencing if a person smiles or versus have a neutral expression? And you can see the data over here. The way the data are formatted, though, is like this. And this would be useful if you had a giant spreadsheet with all the raw data, right? And you just wanted to pick two columns out of there. You would have your data formatted like this. It's not, I don't find it as ideal for a statistics class though, so I don't have any data formatted like this. So for simulations, I will choose things that are already in here, okay? And then for the hypothesis test, it could also be in here, or more likely I'll have you go over to Staplet, okay? Okay, so let's go over the formulas and stuff we're going to use for this in the next video. So I'll see you there.